Okay, so we're talking today about scale. And when you talk about scale, we're not talking about that white stuff in your bathtub. That's also scale. That's a chemical scale. We're talking more about a ratio. So scale the ratio of a drawing length or an object length to the actual length. Scale, the ratio of a drawing length or object length to the actual length. A good example is Google Earth. Let's get rid of that. So there is, Brendan, hit those lights so you guys can see that a little better. Turn the lights off. All right, so we all recognize that that is the church. Is our church and school that small?
No.
Obviously not. It is a scaled drawing. Well, it's not even, it's actually a picture, which is the same as a scale drawing. Let me get to my control here. So let me do it this way. That's smart. No wonder. So I can zoom out, of course, and I can zoom in. I'm changing now the scale, right? The building is now bigger, and therefore the scale has changed. Is it still as big as the actual? Of course not, right? Any picture is in scale. You take a picture of yourself. Is that your actual size? Of course not. You know, you got your selfie stick out there and you're firing off of those selfies. Is that actually your size? No. Is it a ratio of your actual size? Yes. And everything is in proportion. Now, I don't know about you, when I take a picture, I like to get it out of proportion. I don't know if you caught, if you have a picture and you drag it long ways, you get thinner. I like that. Those are good pictures. When I drag them long ways and I look thinner, I never want them to go out sideways. Oh my, then it gets really, 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 really bad. All right. Our property, obviously, to scale drawing. You know, here's, come on, I know what to do. Where's select right here? Let's go. Oh, get rid of Smart Ink. Let's fly around Google Earth. And where are we going? Come on. Oh, we're going to Philadelphia. There's that bridge. Is that bridge actually that size? No. Oh, now we're heading to the city. And all those buildings are scaled. Of course, it's a picture. It's in perfect scale. To the actuality and Philadelphia. All right, I'm not a Philly fan, so let's get rid of Philly. Because I'm from Jersey, right? If we're from Jersey, we're not Philly fans. You guys know what that is, right?
Train. The train track.
So, is that a real train station, or is that a scale of that train? It's scale. This is actually HO scale. These are the smaller trains. Any of you guys have HO scale trains? Okay. My wife's father had the larger scale, and I don't know what exactly the scale was, but the larger ones that used to go around their Christmas tree every year. And then my wife's brother inherited it, and just this Christmas he finally got it going. And so it was nice going around the tree. Well, it's a scale. It's in proportion. It's a ratio. You know, when you make something to scale, everything is shrunk the same amount. So it's a miniature of the original or the real, or an enlargement of the original or the real. In this case, obviously, a miniature of the original or real. In the old days, when they used to make movies, they would make a model of whatever it was they wanted to animate. For example, the Starship Enterprise. All right, if you were a Star Trek fan, all right, live long and prosper. If you were a Trekkie, you know, the way they used to have to make them, they had a model of the Enterprise, and they had to fly that model around and film the model. All right, it was to scale. Any of you guys have the Millennium Falcon? All right. My son had the Millennium Falcon. Who knows? I don't know what was the big ship in the latest one? I have no idea. I haven't seen it. Same one. Still the Millennium Falcon is Millennial? Millennium Falcon. All right, I was right the first time. Falcon? Falcon. All right, sorry. I got the Millennium part right. Falcon. All right, sorry about that. And so again, the idea of scale. And so what we want to do mathematically is be able to determine either an original size based upon the scale, etc. Unfortunately, these days, your generation isn't really understanding how to do maps much anymore, because instead of maps, what does your generation do? Yeah, you guys are a GPS generation. And because you're a GPS generation, you guys are losing the knack and skill of reading a map. So if you look lower in your notes, you'll see this. Brendan, can you get our lights for us again, please? And so take a look at your notes, and here is a map, and let's see, we are in, anybody know what state we're in?
South Carolina.
No.
Georgia.
Actually, it is. Charleston is in South Carolina. Augusta is in
Georgia.
All right, so we're spanning 2 states, actually. We're in Georgia and South Carolina. Quiet, please. And so we have a couple things on our picture here. We have right here the scale. Almost every map will have a scale on it somewhere. And it'll tell you how much distance on the printed map corresponds to how much real distance. Remember, scale, it's a ratio to the actual. Now, if we made the map the actual size, it wouldn't be big enough. You'd fold it up, it still wouldn't fit in your car, right? Obviously. And so there's a scale that tells us, and in this it says 50 miles is 1.5 inches. So every 1.5 inches on this map is 50 miles. So if we took a ruler, we can figure out the distance between Macon, Georgia, and Charleston, South Carolina. And that's what we want to do. We want to figure out the distance between Macon, Georgia, and Charleston, South Carolina. First thing I need you to do is I need you to determine how many inches on the ruler it is between Macon and Charleston. You got to read the ruler. That's not hard to do. I tried to make it easy. Colby?
6.5.
It is 6.5 inches, right? So hopefully you agree that this is 6.5 inches. Is it really 6.5 inches from Macon to Charleston? Obviously not. And the way we want to solve this problem is we want to make a proportion. Make a proportion. Now, we've done this before. We've made proportions before, so that's what we have to remember how to do. And therefore, let me refresh your memory. So to make a proportion are 2 ratios that are equal. So if you remember, a fraction bar, an equal sign, and a fraction bar. Now remember, what are we looking for? We're looking for the distance, and this is the real distance from Macon to Charleston. I'm just abbreviating there, right? You're looking for the real distance from Macon to Charleston. All right, what do you want to call that? Somebody raise your hand and tell me what to call the distance from Kristen. W, all right. So we're going to use W as our variable, all right? Now there are 4 spots in our proportion, yes? Where's the best place to put our variable? Edward?
On the top left.
Top left is by far the easiest way to solve the problem. Okay. Now, you got to go back to proportions, and you have to remember there are two methodologies in solving a proportion. Don't put this part in your notes. Let me just try to refresh your memory. You either need to make the W, the distance from Macon to Georgia, go with, don't do anything yet, its associated value in the bottom, and then therefore then you know what to put on the right-hand fraction. Or the other methodology is to have them correspond in the top, and then you know what to correspond in the bottom. You guys remember which way I prefer? Top and bottom or top and top? Which way do I prefer? I prefer top and bottom. That's my preference. You can do top and top. If that's the way your brain works and it's easier for you to understand, please do so. All right, before I finish this left-hand side then, what will be the units of our final answer? In other words, the distance from Macon to Charleston would be in what kind of units? Say it if you know it. I'm going to put them there just to help me keep track of things. Miles. So the top is distance from Macon to Charleston. The bottom also needs to be distance from Macon to Charleston. So what do I put on the bottom? What do I put on the bottom? Distance from Macon to Charleston. What do I put on the bottom? Hannah? 6.5 what? Inches. I put the 6.5 inches. All right. The distance our map told us. And here let's use black for the other one. Okay. The scale, and that's why I like to do it this way, will go in the other fraction. The scale goes on the other side. Now all you got to do is make sure you put the right thing in the right spot, because we can put the 50 miles on the top and the 1.5 inches on the bottom, or we put the 1.5 inches on the top and the 50 miles on the bottom, right? If we get it backwards, we'll get the problem wrong. So we got to make sure we put it in the right place. And by the way, because we have the units in, we'll figure out whether we did or not once we continue on to the problem, but might as well get it right the first time. So, do I put miles over inches or inches over miles? I'm going to ask you in a minute to make a decision. I'm going to ask you to tell me your decision. So I want everybody thinking, on the right-hand side, should you do miles over inches or inches over miles? So give me one of those on the count of three. You ready? All right, here we go. 1, 2, 3.
Miles over inches.
All right, somebody that said miles over inches, raise your hand and tell me why you said miles over inches. Why did you make that conclusion? Hayden?
Because that one's not there.
Yeah, exactly. You're mirroring the other one. We got to have miles over inches. We have to. It's got to be the same as the one on the left. And therefore, then, we know that the 50 goes with the miles from our scale. And we're going to use a decimal here because it's easier to deal with. And guess what? We have calculators now, right? So let's just use 1.5 inches. It's easier than the 1.5. Somebody raise your hand and tell me how to solve this proportion. How do we solve? Everybody should know how. We've done this before. It's just an equation. We just got to move something. All right. Brendan? How do I do that? What do I do to do it on this one?
6.5 over 1.
Times both sides, right? And again, I always include my units. I'm going to multiply the left by 6.5 inches over 1, and I'm going to multiply the right by 6.5 inches over 1. Will everybody look at the screen for a moment for me? Just hold off on your calculators. I need to make a couple clear points here. On the left, not only do the 6.5s divide out, but the inches do as well, right? Leaving us what should be miles. On the right, again, the inches divide out, leaving my units as miles exactly as I would want. That also helps me to remember to keep my miles. Now, remember, to reduce a fraction, usually we factor, right? But on this kind of a problem, we're just simply going to use our calculator. So we're not worried about reducing at all. The calculator is going to take care of everything. Now, how do you punch something like this into your calculator? there are two different ways. My advice is multiply all your tops and then divide by your bottoms. So my advice is punch in 50 times 6.5, then hit your divide by button 1.5 and see what it tells you. So go ahead and do that. 50 times 6.5, divide it by 1.5, and I'll try to remind you guys often that once we start using our calculators, almost every time we will round off to one decimal place unless we're told otherwise. So there are two, listen to me for a second, there are two conditions that will cause us not to round off to one decimal place. The first condition is if we're told to round off to some other place. For example, you're doing homework and it says round to the 100th. And you got to round to the 100th. If you're doing homework and it doesn't say, what do you round to? The 10th. If you're doing a test or quiz question and it doesn't say, what do you round to? The 10th. However, there is one second condition. Let's suppose you're using your calculator and you end up with an answer that actually stops at either the second decimal place, there's no more numbers, or the third decimal place, there's no more numbers. In that case, you'd write the whole thing because it doesn't go on forever. It stops all by itself. Let's write the exact answer in that case. Let's not round off. For example, what if you had the number 2.79? I wouldn't round that off to 2.8. Why should I? I can write the whole exact answer 2.79. So that's the other condition when you might go more than one decimal place. So two situations. If the directions specifically say to go to a definite place, and the other is the only reason you go more than one decimal place, oh, and there's actually a third, is if the number stops. Of course, the third is what always goes to two decimal places. What always goes to two decimal places? Money, right? So you got to be aware of money. It's because money's always to the penny, right? Okay. So, who's got, somebody raise your hand. Juliana, what do you got for an answer? The MAMS doesn't like that answer. Okay? Would the MAMS like 10,000 something miles? How far is it across the whole United States, roughly? 3,000 miles. The whole diameter of the Earth is only roughly 8,000 miles, okay? So the MAMS doesn't like that answer. You must have punched in something wrong. Amber, what do you got? What's the round off? Was it even?
No.
216 point what? What's the round? Well, I just got done telling you how to round off. 0.7. And what's our units? Miles. So 216.7 miles. Hey, somebody might say, Mr. Scarfi, what if I put 216.6 bar? Isn't that like giving an exact answer? So would that be one of the exceptions? It would be, isn't? If this is 216.6666, this is then an exact answer, and that would be an except. I'll take it either way in that situation. So don't fear if you say, well, I could use a bar and get an exact answer. Chloe. Your calculator is rounding off. You gotta know what's going on. See, calculators used to be, the calculator gave you the number exactly, and nowadays some smarty pants thought it would be great if the calculator rounded off at the end. That was a bad choice. And so the programmers now program your calculators round off at that last digit, not smart. Okay? That was not a good move. Every idea somebody comes up with isn't always necessarily a good idea. And in my opinion, that was a bad idea. Kristen. Yes. All right, number 2. Brendan, you have a question?
What did the blank say?
Oh, did I have a blank? Where did I have a blank? Oh, way up there. Thank you, sir. I was so anxious to get to my problem here. All right, let's fill in a couple of those blanks. A scale drawing is one where now we're talking about a drawing lengths. are at the same scale as the original. A scale drawing is one where all lengths are in the same scale as the original. And this is the key, and this is what we did. Use a proportion to solve. Use a proportion to solve. All right. So let's continue on, do a few more examples, and that'll be it, and not a whole lot to this lesson. Okay. So use the given scale to find the actual size of the car. Obviously, the car isn't really that size, otherwise you'd have to be a midget to drive it. All right? Unless you're at the zoo, or no, not the zoo, at the circus, and then all the clowns get out of the clown car, all right? But it's still a little bigger than that. All right, so again, what we're going to try to do is we are going to try to determine then the actual size of the car. So how do you start these kind of problems? With a what? With a what kind of thing? With a proportion. So we need to start this with a proportion. I like using n for my variable. I'm going to put it in the top. Okay, so in this one, the scale is given a little bit different. So we're going to figure that out here in just a little bit. Now, you got to measure the car, right? That's what's going to go on the bottom. The distance we're looking for of the original divided by the distance from measuring. Now, be careful here. Look at where the ruler is and be careful with what you come up with. Okay? So somebody raise your hand and tell me, what is the distance of that car? Colby.
1.5 inches.
How many?
1.5.
Not quite. Omar, what do you think the length of that car is?
8.5.
Yeah, you got to be careful. This actually, the ruler was started at 1, not at 0. So be careful sometimes. I didn't make this up. Whoever made the graphic chose it that way, so be careful. So on the bottom is 8.5 inches. Okay. Now this one's a little odd. You usually won't get a problem like this, but I chose it because it was nice and illustrated, and I can also teach you what happens in this kind of a situation. The scale is 1 to 18. 1 to 18. Did they give us any units in the scale? And the answer is no. Therefore, the units of the scale of the actual match. What is our ruler in? What kind of units? So it's saying every 1 inch is going to equal 18 inches in reality. Every 1 inch is going to equal 18 inches in reality. So this one's a little trickier in that what number goes on the top, the 1 or the 18? Which numbers goes on the bottom, the 1 or the 18? Obviously, if we get it wrong, we're going to get a wrong answer. So we put the 18 on the top, do we put the 1 on the top? So here's the question. Is this n on top? Are we expecting a bigger number than 8.5 or a smaller number? Bigger. Which is bigger, 18 or 1? 18. So the 18 inches should go on the top and the 1 inch goes on the bottom. Again, the right-hand fraction is your scale. Now, I know that's a lot of thinking there, but there's no other way to do the problem. You got to do a little thinking. You guys will notice that proportions, when you set them up this way, solve always the same way. I'm going to multiply the left by 8.5 inches to move that, right? And whatever I do to the left side, I'm going to do the same thing to the right side. All right. Grab your calculators. By the way, what units will our answer be in? Inches. We know that because we included them. So go ahead and belt that out. Calculators out. Top times top. 18 times 8.5. Dividing by 1 is boring. And in this situation, What is the length of the car? Emily?
153 inches.
Say it again.
153.
150. Anybody agree? 153 inches. Okay. 153 inches. Do we usually talk about, now that is, by the way, what the proportion gives us, according to this scale, 153 inches. All right, I don't know about you, but if I look at a car, I usually don't say, I think that car is about, 153 inches. What would I say instead? That car looks to be about 8 feet long, all right? 6 feet long, 10 feet long. All right, so do you remember how to convert inches to feet? Well, I taught you the conversion factor way. What do you want to change? Inches. Remember, whatever's on the top, you put the same thing on the bottom. Do you know how many inches in a foot or feet in an inch? You should. So what numbers do I use here in this conversion factor? Tell me, somebody raise your hand, tell me where to put my numbers. Somebody raise your hand, tell me. Daniel? So Daniel's saying every 1 foot is 12 inches. Is that true? That is true. Notice our inches divide out, leaving us feet, which is what we want. Now you would take your calculator and you would take 153 the top and divide it by the 12 on the bottom. According to this, somebody read their answer for me. Raph, you've been quiet today. What are you getting for an answer here? 153 divided 12.75, and what will our units be, Raph? Feet. This might be a distortion. Are cars usually 12 feet long? I don't know. I'll have to get a tape measure out sometime and see. That seems awful long to me, 12 feet. I'm going to have to pace off my car next time. We'll find out. All right. Edward, are you eating a mint or something? Or let me ask. Candy. Bring it up to me, please. I mean the stash of the candy. All the rest. Hope it's something good. Oh, look at that. Pick those up, please. Thank you. Any more in that pocket? You sure you're empty? All right. Thank you. Okay, so 12.75 feet is the length of our car. Christina. You have to leave at 12:30. So again, the homework's at the bottom of the page, so you can see what to do. So here's a similar situation. Now the car is in 1 to 24 scale. So we'd set it up the same way. And finally, the third situation, 1 to 43 scale. And again, we do it all the exact same way. I'm going to skip that for time's sake. They're all exactly the same kind of problem, right? Only in each situation, the scale has changed. In this second picture, the car looks to be, what, 6 inches long. Again, I don't know why they keep starting at 1. And again, here they start at 1. This last one, the car is 3 inches. 3 inches, 6 inches. You could run the numbers. In that middle one, you would end up with 12 feet. Should end up the same if it was perfect. The illustration's not. The bottom one, you end up at 10.75 feet. Let's do this last problem, though, and that's the one I wanted to get to. All right, so we're looking at this. The scale on a map is 3 centimeters equals 2 meters. If the distance from A to B is 11 centimeters on a map, then how far is the actual distance? So somebody raise your hand and tell me how to start this problem. Edward?
You do the proportion.
We've got to do a proportion. So somebody raise your hand and tell me what you would want to put on the left side of the proportion. And whatever you tell me, I'm going to do it exactly what you say. Somebody give me the left side of the proportion. Come on, participate. Participate. Think. Nia? What do you want to use? N, all right. And what would you like to go on the bottom? No problem. Take a minute and think. All right, so let me ask everybody before you write it, how many would agree? Let's put the 11 centimeters on the bottom. That is the correct move. Okay. The 11 centimeters definitely goes on the bottom. Now what we have left, remember, this side is always the scale, right? And here is our scale, correct? So all we got to do is make sure we get the right number with its unit in the right spot. We could have it upside down, we'll get the problem wrong. We don't want to do that. So, what goes where? Allison?
It's like the 2 meters on and 3 centimeters on the bottom.
How many would agree you put the 2 meters on top and the 3 centimeters on the bottom? Julia, why would you want to do it that way?
Because it's the same.
Couldn't hear the last part?
It's the same way on
Okay, and what particularly shows you it's the same way? What are you looking at to know that?
centimeters.
The centimeters are both on the bottom, correct, right? We didn't put a unit on the top, and sometimes you won't because you won't be sure. But because centimeters are on the bottom, we know it's got to go that way. Okay, finish it off. I'm going to pause the video. Hopefully you decided to multiply both sides by 11 centimeters over 1 as we isolate our variable. Our centimeters divide out as well, telling me my final units are meters. Somebody raise their hand and tell me how to write the final answer. Ashley? 7.3 meters. And I think this one you can use a bar on, but I would take it either way. So the round off is 7.3. This one we can do exact because it's 0.333333333, and we can use a bar. Any questions on that? Anybody? Any questions on that? Okay, so a few problems there for tonight, and then we'll roll on as we do some scale.